Good morning, good afternoon, good evening, good wherever you are, and welcome to this SNEA ESF presentation from the Ethernet Storage Forum on Fibre Channel versus iSCSI. Today we are joined by two experts in the field. Fred Knight of NetApp, who, if any of you know anything about Fibre Channel, will know that Fred is possibly what I would describe as a Mr. Fibre Channel. And John Kim, who's the SNEA ESF chair and works at Mellanox. I am Alex McDonald, and I'm going to be your host for today's session. Before we go very much further, just let me introduce you to the interface. Somewhere on your screen, you will have the ability to enlarge the interface should you want to see anything in a bit more detail. We don't have very many diagrams today, and the text is relatively large, so it should be okay to a smaller viewport. But if you do want something larger, there is a button that you can make the whole screen expand to the full size of your desktop. The other thing that you also have are two things I would like you to do. First of all, there's a question button where you can ask Fred, John, myself a question live during this presentation. What we will do, because we've got a very large audience today, what we will do is try and answer as many of these as we can as we go through the session, but we will collect them all up and at the end answer them and post them up to the SNEA ESF website, a link to which I'll give you right at the back end of the presentation, along with a copy of the presentation, so you actually get a full set of information from today's webcast. The other thing you're going to do for me on the way out is rate this webcast. We are really interested in what you think about it. We're really interested in knowing whether this is a 1, I wish I'd stayed on the golf course, to a 5, more please. This is the kind of thing we really like. And if you leave some comments for us, that would be much appreciated too. So, just to introduce you a little to SNEA, the Storage Networking Industry Association. This is us at a glance. We're 170 industry-leading organizations in the storage arena. We've got about 2,500 active contributing members. And we've got 50,000 end users and storage professionals worldwide that we can get in contact with at the drop of a hat to do things like this and to let you know about things like this WebEx. You can learn more about us at snea.org/technical. We've also got a Twitter handle at SNEA. You may want to follow us on Twitter. In terms of this presentation, just a quick legal notice. This basically says that the slides are copyright of SNEA. We'd really appreciate it if you do use the slides, and you're welcome to. There'll be a PDF posted up, but you keep in place the fact that this is our copyright, belongs to SNEA, and that if anything you do based on these slides manages to break into two parts, I'm afraid both of them are yours. We don't provide any warranties for this presentation. So without further ado, I'd like to say good evening, Fred. How are you? Just make sure Fred's still there. He's not got himself on mute.
Well, I just came off mute, and I'm here, ready to go.
Excellent. Well, that was a good start. And good evening, John. Just to make sure you're not on mute either.
I'm here, Alex. Good day to
That's
you,
excellent.
or good evening to you.
Good evening. So, without further ado, I'm just going to run very briefly through the agenda and the format of today's webcast. We're going to do a brief history, a little potted history of where we are with Fibre Channel, and Fred's going to do that. And then John's going to take us through a little brief history of iSCSI. And once we've done that, we're going to compare and contrast. We're going to do a few similarities and differences. But what we are then going to do is ask the question, and I think we're going to get the answer is not really. I want to make that clear at the front. This really isn't a cage match in that sense. Is one better than the other? I think one, you will see Fibre Channel has more advantages in some areas. iSCSI has more advantages in others. So we're going to go through some of these. We're going to get challenge topics, and I'm going to ask them 6 questions about things like, for instance, performance, manageability, security. And we're also going to talk a little about the future before we wrap up with some really good pointers to further Fibre Channel and iSCSI material. So without further ado, Fred, I'm going to ask you to take us through what is Fibre Channel.
Well, Fibre Channel is a block storage network technology. It is a set of layers of communication protocol that move blocks of data back and forth between a host and a storage device. It began in the early 1990s. The first standard was completed and published in 1994, and that was for the 1 gigabit products. But there were products before that. In fact, they had what they called quarter speed and half speed, if you go back far enough, because they wanted the standard to start at 1 gig. So those early products had to come up with something else for their name. But when you hear the word fiber channel, when you hear people talking about fiber channel, they're generally not talking about everything associated with fiber channel. They're typically talking about SCSI that's using FCP over the fiber channel wire, because there are many other things that can use fiber channel. So here's a pictorial of the layers that fiber channel uses. You see we have the upper layer protocols, the ULPs, be it SCSI, FICON, used by the mainframes, NVMe, or several other different protocols. And then the layers down through the networking stack for moving the storage data across the network. The services, the signaling, all the way down to the physical layer. So fiber channel was originally built specifically for storage. That was the primary purpose. It was optimized out of the box. You plug it in, you connect it up, and it just operates in its optimal form. It doesn't take a substantial amount of configuration, although configuration options do exist. They're not something that you have to tune and tweak and play with. They do use different adapters and switches than your network protocol. There are adapters and switches that are dedicated to storage, that are purpose-built for storage, for moving those blocks of data back and forth. So primarily, fiber channel networks are the two topologies, point-to-point or switched. For those that remember the history of fiber channel, there was an arbitrated loop technology, but that technology is mostly gone out of use these days. And we have point-to-point or switched fabrics. So while the protocol allows for other operation, it is primarily for storage, and that's the primary use case today. When it was originally built, there were all sorts of different protocols layered on top of it, including TCP/IP, although that did not come into wide use in the industry. So it's purpose-built for storage. It is what I would call centrally managed, that the network switches all communicate with each other. Management actions that are taken on one switch are propagated through the other switches, that you're communicating with the network itself, the services in the fabric to do that management. It's primarily a lossless in-order delivery, but it is a reusable protocol. As I mentioned, SCSI is the primary use case today, although the mainframe people might argue with me because as far as they're concerned, FICON is the main use case. We also have NVMe now coming into the fiber channel space. And for any of our aircraft people out there that realize fiber channel is even used in fighter jets for weapons control systems and other kind of avionics material. So it has some broad capabilities, even though it was purpose-built for storage. So for the reliability, one of the important things in fiber channel is the CRC, that it results in the ability to detect errors and make sure that those errors are either corrected for small ranges of errors or that they are detected, that you don't have undetected errors that are occurring. That's one of the places we'll get to talk about some differences, is the formulas that are used for calculating the CRCs. For redundancy, typically within fiber channel, you'll find duplicate SANs. The duplicate networks will be set up so that if there is a failure in one, then the other network is there to take over. So that type of redundancy basically means that the protocol itself is fairly simple. You don't have a lot of complex multipathing happening within the network protocol itself, within the fabric protocol itself. Now, there are, of course, the ability to hook up multiple paths between switches. They use the OSFP basic algorithms for finding the shortest path and using that path. But that's not something that gets exposed to the endpoint devices. That's something that's transparent within the fabric. So the complexity of the multipathing and redundancy used by the hosts and the storage devices is not actually in the network. It's in the software in the host itself. I think most people are familiar with how that works in the host with the multipathing drivers and such. So another service of Fibre Channel are the services that it provides, the zoning capabilities, the name server operation, and its security functions. That with the zoning operation, you can manually define which nodes within the fabric are allowed to communicate with each other, or a feature that was just been added within the last couple of years is something called peer zoning, where if you tell an end device who it's allowed to communicate with, then that end device can now communicate that information into the fabric so that the zoning operations all become automatic. That the information is just communicated from the end device to the zoning manager within the fabric. The name server is a point of registration within the fabric where devices indicate their presence and where devices can be discovered, where hosts can go discover the storage devices without having any manual intervention required. There's also notifications of state changes if devices come, if devices go. Anytime there's a change in the fabric, then the endpoints can find out about the state changes that are relevant for their operation. For security, both encryption and authentication are available. The authentication is done through a standard called FCSP2. That standard also is where the negotiation occurs for how to do encryption. And then the FS4 standard is the standard involved in doing the encryption and passing the encrypted data across the wire. So we have both authentication and encryption capability. As far as the speeds and feeds, Fibre Channel, as I mentioned, started at 1 gig as its first official standardized product and has grown in a 2x fashion, 2, 4, 8, 16, all the way up now to 128 gig Fibre Channel connections. So the 256 is in development now. In addition, they're working on a 1 gig or a 128 gig with one wire. Because the current 128 gig, you can see, is a by 4 combination. It uses 4 32 gig channels to be able to create a single 128 gig wire. So on the roadmap, there are speeds up to a terabit. So those things will be coming out over the next few years, mostly as the market demand and requirements make the vendors move forward in some of those speeds. In addition, the NVMe protocol is also being carried over Fibre Channel, and that's called FC NVMe. We'll get to talk a little bit more about that at the end as Alex drives us into some of our futures discussions.
So, thank you, Fred. Before we get on to, me moving too quickly over the slides, I beg your pardon. Before we get into that, just let me revisit the agenda again and point out that somebody has already got out in the spirit of this. They've asked a question that I'm actually going to ask towards the end because it actually fits in with one of the challenges. But it actually mentions the word the death of. So, hey, we've got somebody who really wants to stir it up here. Let's see what it is when we get towards the end. Now, John, I'm going to ask you to actually take us through a brief history of iSCSI.
Excellent. Thank you, Alex, and thank you, Fred. So let's talk about an overview of iSCSI. So iSCSI is also a block storage network technology or storage networking technology. It's the SCSI protocol running over TCP/IP. Now, actually, it can run over other protocols like RDMA, which would be like InfiniBand, iWarp, or Rocky. But the vast majority of iSCSI deployments do run over TCP/IP, and therefore it's almost always over Ethernet as the network and the transport. It's standardized, rather than being standardized by T11 and ANSI, this is standardized by the IETF, the Internet Engineering Task Force, through various RFCs, some of which are listed here. The most important ones are listed here, but there are several others. So it hasn't been around as long as Fibre Channel. iSCSI started about 6 or 7 years after Fibre Channel. The standard, I don't remember exactly when it was done, probably around 2001 or 2002, but the first available products came out in 2003, 2005, and 2006 for the operating systems or hypervisors listed here. So starting, I think, first with Solaris in 2002, and then Windows in 2003, and so forth. When people say iSCSI today, they usually mean, they almost always mean, it's the SCSI protocol, and running on top of the iSCSI transport, or actually iSCSI protocol. It's a SCSI commands on top of the iSCSI protocol running over TCP/IP on an Ethernet layer. So the vast majority of the time, that's what they mean by iSCSI. So Fred explained that Fibre Channel uses a 5-layer model. iSCSI is built on the OSI 7-layer network model, which we've illustrated here. So you have your applications running on top of the SCSI protocol. And the SCSI protocol then has basically 3 ways you can transport it in terms of the storage networking protocol. You have regular iSCSI, you have ISER, which can run over iWarp, you have ISER, which can run over RoCE. And RoCE is RDMA over converged Ethernet. And then these protocols, whether it's regular SCSI or the RDMA versions, run over either TCP or UDP, which run over IP, and then either the layer 1 and layer 2 Ethernet, the physical and the link layers. In terms of speed, iSCSI is just the protocol, so it doesn't have its own transport, but it runs on Ethernet, and the Ethernet speeds had been increasing roughly 10x about roughly every 5 years. Now, as Fred pointed out, Fibre Channel started at 1 gig. Ethernet started a little bit slower than that at 10 meg. I don't remember if there was a 1 meg before that, but there was 10 megabit, then 100 megabit, and then it slowly evolved over 1, 10, and 100 gigabit, and along the way they've added 25, 50, and then 2.5 and 5 gig Ethernet speeds as well. Going forward, the speed of Ethernet is expected to, instead of going 10x every 5 years, it's expected to double every 3 to 4 years. And in fact, I think later we'll cover the fact that a lot of the new speed development in terms of the wires and the networking wires is actually going to be based on the same technology for both Fibre Channel and Ethernet going forward. Now, Fred pointed out Fibre Channel as a transport can support NVMe over fabrics. iSCSI as a protocol does not, but it runs on Ethernet, and Ethernet can also support NVMe over fabrics, just not using iSCSI. Now, iSCSI as a protocol was also built for storage, much like the Fibre Channel protocol, but it runs on Ethernet, and the Ethernet network was not originally built for storage. It's built as a general purpose network, which can be used for storage, but is initially used mostly for other things. So it's an all-purpose network. iSCSI, again, as a protocol, hooking it up, I would say it works pretty much works out of the box for connectivity. However, there's a lot of discovery or tuning which requires manual configuration. Going forward, there are some new developments, some software or some new switches that will automate parts of that, but generally speaking, discovery in iSCSI is not an automatic method today, or automatic affair today. It has to be done manually. And usually just making it work is easy, but getting the best performance requires tuning or configuration or making some specific choices on your network hardware and software to get the highest levels of performance from iSCSI. You can have a dedicated or shared network, so that could be seen as both good in flexibility, and it also means that you may have to do some more planning to figure out, do I want a dedicated network just for my iSCSI traffic, or am I going to share it with other Ethernet traffic? And Fred and I will discuss that more a little bit later. In terms of management, the management of iSCSI is generally distributed. It's more in the clients and the storage targets or storage arrays, and less in the switches or less in the network, which is where Fibre Channel has most of its management in the network. Now, I see that going forward, I think some of that's going to change, and there'll be more iSCSI management in the switches as a future. But again, today it's mostly on the endpoints. The transport can be configured as lossless or lossy. So if it uses regular TCP, that's usually a lossy network. Doesn't mean that it could lose packets. Doesn't mean it will lose packets, but it could. But you also have the option to configure iSCSI over a lossless Ethernet network as well. And the underlying network is reusable for many things. So while Fibre Channel can also, as Fred pointed out, Fibre Channel can run different protocols on top, but it's generally used just for storage, or maybe running fighter jets. where Ethernet is used for lots of things all the time. Other storage protocols, you can use it for scale-out file systems, or you can use it for compute traffic or hyperconverged infrastructure. These can all run on Ethernet in addition to iSCSI. So they don't run on iSCSI, but iSCSI and these other types of storage protocols or non-storage traffic can share the same Ethernet network. In terms of reliability, iSCSI has a digest, which is, again, a cyclical redundancy check, or CRC. And underneath it, Ethernet, and then TCP if you're using it, or RDMA if you're using that, also have their own either checksums or CRCs. The redundancy in iSCSI it can be done at the protocol level or at the physical level. I would say it's done more often at the protocol level. You can use either link aggregation or iSCSI multipathing, so you have two choices there. And there are some customers who build duplicate Ethernet networks, as you do with Fibre Channel. The difference is that generally what I see, and we can talk about this more later, that maybe customers are running lower speeds or they're running maybe tier 2 storage are more likely to not have this redundant network. And customers who are running higher iSCSI and higher speeds or have more critical workloads are probably going to build that fully redundant Ethernet network for their iSCSI traffic. In terms of services, iSCSI does have some zoning or isolation options. It works a little bit differently than Fibre Channel. So you could build a physically separate network. You can use access control lists, or ACLs, to do something that's basically like LUN zoning. You can use virtual LANs, and that's often used from a security standpoint to separate different servers or different workloads or different storage arrays. And you can also use a VPN to help isolate the traffic, or virtual private network, to isolate traffic between either different hosts or different storage targets. There is an iSCSI storage name service, ISNS. My impression is it's not used as often. It's not so popular today. And then on the QoS and monitoring side, you have a lot of Ethernet tools. So you can use some of them or all of them or none of them. So there are a lot of tools. Ethernet's, of course, developed a lot of these types of tools for monitoring and management and even QoS. But you have to decide which ones you're going to use or if you're going to use them at all. On the security side, there's IPsec for encryption. So it's encrypting at the TCP IP level. And then there's CHAP or Radius for authentication if you want to verify that the right people are connecting to the right servers. In terms of the speeds, so the speeds are obviously, well, actually it's originally started at like 100 megabit, but effectively you have from 1 gigabit up to 100 gigabit today. And 100 gigabit is actually shipping, or has been shipping actually for a while for iSCSI. So I wouldn't say too many people are actually using it for iSCSI yet, but it is out there and we have seen some deployments. And in the future, the speeds, I'm expecting later in 2018, probably towards the end of 2018, there will be some vendors shipping products that do 200 gigabit, which is 4 channels of 50, and there will be 400 gigabit, which is 8 channels of 50, but at least initially, the 400 gigabit will not be from the servers to the storage. It'll be from switch to switch. And then later in the future, farther out, as they develop 100 gigabit Ethernet, where one Ethernet channel can do 100 gigabit, then you'll have the option to do 400 gigabit to one server, as well as 800 gigabit or other technologies that can use 100 gigabit per lane. But those dates are farther out and harder to predict. As mentioned, NVMe over fabrics can run on over Ethernet. It doesn't run over iSCSI, but they can run on the same type of networking technology. Okay, I thought I was advancing the slide. Let me try that again. Oh, I went too far, Alex. I think we're back to you.
That's okay. Don't worry. I'll move back one.
Sorry, I also went back. I'll stop touching the keyboard and let you move the slides.
That's fine. This is one of the miracles of modern technology, actually. There are 3 of us giving this presentation. None of us in the same office. In fact, I think we're all separated collectively by about 7,000 or 8,000 miles. So anyway, I just wanted to cover very quickly because there was actually one question, what about FCOE? And you may have questions about other mixed technology like running Fibre Channel, Ethernet, or NVMe. There are a large number of presentations that SNEA have, and one of them I put in the announcement, which is a Fibre Channel Ethernet presentation that you might want to go and take a copy of. I'm going to stop displaying that for the moment now, because we've got other questions I just want to cover while we're here. But just to put it in context, there are other block protocols. There's Fibre Channel over Ethernet. We've got SCSI with Fibre Channel protocol over lossless Ethernet. It's often used on blade type servers. There's SRP, which is a SCSI RDMA protocol that runs on InfiniBand, mainly used by people doing HPC. And there's non-volatile memory express, which is the SSD form factor inside a server that can run over fabrics. And it's a bit of a new kid on the block in terms of protocols. And we've also got NVMe running over RDMA or Fibre Channel, and there may be even NVMe running over TCP/IP very shortly as well. So there's a mixed number of protocols and fabrics there. In terms of things to remember, one of the things I think we need to emphasize here is that applications can use either Fibre Channel or iSCSI. That your block protocols are fairly promiscuous in the sense they can be used by just about any application out there. The thing that they're delivering are the SCSI commands, the commands that disk drives respond to in terms of LUNs. They both deliver those SCSI commands seamlessly in terms of the end user application. And most OSs and hypervisors support both Fibre Channel and iSCSI. And again, the arrays, the storage arrays, the SANs at the back end also both support Fibre Channel and iSCSI. It's fairly unusual to find these days an array that doesn't support both of them. The other thing to remember is the cabling is often the same. The physical infrastructure, apart from some minor details to do with primarily the connectors, the cabling is often the same, and we use the same optics for running Ethernet as we can for Fibre Channel. So there are some key differences though, and those we're going to explore with the challenge questions in a second, once I've actually looked at some of these questions. Gosh, we've got quite a few actually, it's quite a few here. I'm going to try the one about the death of, I'll get to later, because I think that one is actually quite a good question for you two guys. But let me just ask you both here. I'm going to ask Fred first and then John. In terms of multipathing, are we using it for load balancing or high availability when we're building a Fibre Channel network?
It's actually useful for both environments. Where you need the load balancing, you can get additional bandwidth by having multiple paths. One way to increase performance is add more paths. And it's also useful for redundancy, that if one of the paths dies, then you've got an alternate path available to continue performing the I/O. So I think the answer is both.
I'd agree with Fred. It's good for both. On the iSCSI side, there are different ways to set it up. Some ways are active-passive, so then you get redundancy but no extra bandwidth. And with active-active, you get redundancy and extra bandwidth.
Okay. And I think this is a really good question as well for both of you. We use a lot of acronyms today. Now, SNIA has a dictionary. There's actually a SNIA dictionary that covers a lot of this. And I'll put it in the announcements section in a second so you can see the dictionary for yourself. But can somebody define RDMA for me? John?
Sure. RDMA means Remote Direct Memory Access. It allows one machine to access the memory of another machine or a storage box directly over the network, bypassing some of the kernel layer and without duplicating, without making extra copies of the data. So it's a more efficient way of doing networking that can run over Ethernet or InfiniBand. But interestingly enough, and so it's really efficient and uses hardware offloads. But interestingly enough, I would say, and Fred can comment here, that Fibre Channel, while it doesn't do RDMA, also has some similar hardware offloads to help increase the network efficiency.
Fibre Channel has been DMA since day one. Storage adapters originally, back in the 60s and 70s and 80s, were all direct memory access adapters that moved the storage without moved the data without copying. Fibre Channel took that same model. So there's no need in Fibre Channel to add RDMA. That was something that was created for Ethernet and InfiniBand well after Fibre Channel products were shipping. So it really is the same capability with just a slightly different name.
Good, thank you. So I've actually put I think it's a really valuable resource, and we don't push it enough. There's a paperback form of this that some of you may have seen, but I think the online version is, which is simply a copy of the paperback, or the paperback is a copy of the online version, whichever way you want to look at it. But the online version is out there, and it's really useful for decoding some of these acronyms. And you'll see the link there to our dictionary, and RDMA is covered in that, as are all the terms that we've used today, by the way. So things like FCOE, iSCSI, SCSI, they will all be covered in the SNIA dictionary. So we have lots and lots of questions here, and I'm not quite sure that we're going to get through some of these. But remember, what we'll do at the end of this presentation is only give you a link to the presentation, but also we'll be posting up at some point within the week on the SNEA ESF blog the answers to all the questions that have been asked today. And we've got quite a few, because we've got a huge viewing number. There appear to be around about 560 people viewing this presentation, which is quite remarkable. So without further ado, this is when I want to get on to the challenge questions. Now, don't take from the boxing analogy that A, John, Fred, or I are necessarily particularly fond of boxing. We're not. Or that B, that's necessarily a winner or loser in this. There isn't. But we just thought we'd use the kind of analogy. I'm going to try and get a little bit of, not friction going between the two, but I'd like to explore the differences and the similarities between Fibre Channel and iSCSI solutions as we go through. And if you've got questions that relate to that, just ask them and I'll see if I can get to them. So our first question is about performance, and I know there were a couple of questions about performance here. And I'm going to, first of all, I'm going to ask Fred, which offers better performance? We've got two types, I think, of performance that we identify. The first is bandwidth or throughput, and the second is latency, how long it takes to get you an answer, as opposed to how many answers you can get through the pipe. And who do you think is winning this speed race? Is distance important? And what are the issues around providing high performance in terms of bandwidth and latency? So Fred, you first.
Well, I think the most important thing in any kind of comparison is comparing apples to apples. If you try and compare apples to pineapples, you're going to find that they taste really different. So if we're comparing a shared network running all sorts of TCP traffic, it's also running a software-based iSCSI, and we try and compare that to a Fibre Channel network, then the Fibre Channel network is going to win. It's a dedicated network with hardware-based adapters. On the other hand, if we're going to compare a dedicated 100 gig Ethernet network using offloaded DCE-type iSCSI adapters, DCE is the Data Center Ethernet acronym. If we're going to try and compare that to a 2 gig or 4 gig or even a 16 gig Fibre Channel, then certainly the Ethernet network is going to win. So we want to make sure that we're comparing apples to apples. Fibre Channel is always full DMA, so it delivers a pretty deterministic latency. The switches all have resources that are dedicated ahead of time, so the adapters all know what they can do ahead of time. So that's a little bit different than a shared Ethernet network. If you have a dedicated Ethernet network, then you're going to have more of the same capabilities. Yes, and the question about servers supporting that high bandwidth, yeah, it's there. If you're looking at a high core count server, if you've got 32, 64 cores, something like that, you're running in a virtualized environment where those cores are just screaming I/O out through the virtualizing subsystem, then yes, you're going to be fully capable of driving some of those high bandwidths. So
your answer is, I suspect, is it depends. So I'm going to bring John in here to find out what the other side of it depends is. John, what do you see from a Ethernet, an iSCSI perspective?
So I would have to say Fred gave a pretty good answer, and I would agree with pretty much everything he said, that it depends a lot on how you set up the underlying network. If you have a shared 10 gig Ethernet network with TCP/IP and no offloads, then as Fred said, Fibre Channel is going to have higher throughput and lower latency and more deterministic or more predictable, less long tail latency. And then if you have a dedicated Ethernet network, maybe with you can use with hardware offloads on the adapters, and then there are different kinds of offloads available, then you may very well get higher bandwidth and lower latency from the Ethernet side, depending how you configure it. In terms of how much can servers use, I would say most servers can't use the 100 gig, but there are a few that can, and the number is slowly growing. So there's some servers either in machine learning, artificial intelligence, in editing uncompressed high-definition video. There are a small number of servers, and again, that number is growing, that can use or would want that really high bandwidth of the 50 or 64 or 100 gigabit per second. And I think going forward in the future, there will be servers, not too distant future, there'll be servers that want even 200 gig. So again, today most of the servers are happy with like 10, 25, 40 gig or 32 gig of performance. But and in some cases, the all-flash storage arrays can use more. So you may have a case where the servers need, again, 25 or 32 or 650 or 64 gigabits, but the storage could be using more than that because each storage array may be supporting several servers.
Okay. I have an apology to make as well to the audience. Apparently RDMA is not in the dictionary. My sincerest apologies. We'll get that fixed. I've got a note. We've actually got somebody listening in who works for SNIA, and she's going to make a note for me to get RDMA added to the dictionary. That's a big omission. I didn't realize. I do beg your pardon. The other question I had here, and this is the one that came in very early, and I think is a cracker as related to performance was, and I'm going to read the whole thing because I think this kind of gives the flavor, I think, of where people sometimes are thinking about this. So, you guys, with 400 gigabit per second Ethernet on the horizon, cloud providers and enterprises adopting hyperconverged architectures based on Ethernet, isn't this finally the death of Fibre Channel, at least in the mainstream, with perhaps the exception of some niche verticals which perhaps run mainframes? I mean, that's a contentious statement. Fred, I think you might want to defend that one.
Well, first of all, I'll take the last bullet that's on the screen, that in reality, both the Ethernet group and the Fibre Channel group work with the same underlying technology. There's the OIF, the Optical Internetworking Foundation or Forum, the COBO group, which is the Consortium for Onboard Optics. Those groups work to produce the hardware that actually drives these technologies, and both Fibre Channel and Ethernet use it. So the fact that you hear about a speed 400 gig Ethernet, for example, and you haven't yet heard about the equivalent speed in Fibre Channel, just means that the groups are doing their marketing a little bit differently because the underlying technology is basically the same. When Ethernet comes out with 200 gig, Fibre Channel will have 256 gig. And when Ethernet did 100 gig, Fibre Channel was working on 128. So the technologies are all there, and the speeds will follow. The question will be where the market goes. Obviously, one way to think of it is, the profits from one technology drive the future of the next generation of technology. So as long as companies are moving forward, there will be new speed bumps. There will be new generations coming along.
John?
So I would say, even though I'm not a big fan of Fibre Channel, it's never going to die. At least not in my career. Not in my career. It's going to be around for many, many, many years because there are certain workloads and applications that like it. I would say that for the last few years, and I believe this will continue, there has been a decline, a slow decline in the number of Fibre Channel ports that people deploy each year. But it's going to be around for a long time. Fred's absolutely right on the electrical side, or on the actual cabling and the physical interface. Ethernet and Fibre Channel are now developing on pretty much the same technology. I would argue that Ethernet, at least recently, is bringing some of the fast technologies to market in terms of available products a little faster. But I think the more interesting part of this question is, what they have said about cloud and hyperconverged. But perhaps I think we may want to address that. Alex, I'll leave it up to you if that is a better address as we get to some of the later slides in this webcast.
I was actually thinking of Mark Twain, to be quite frank, and the statements about tape as well. The reports of my death are greatly exaggerated. I think Mark Twain was in the position of having once read his obituary. I think perhaps from my perspective, certainly, that as a storage medium, tape is still here and still alive, more than alive and kicking, in fact. And I think the same will be true of Fibre Channel for some time to come. So anyway, enough of challenge question number one in terms of performance. Thanks for your questions, by the way. Keep them coming. We've got quite a few, so I'm not going to get through them all, but I will try and get around to your question if it's appropriate at the point we're talking about. So, challenge question number two is one that's, I think, really important, because it doesn't matter how fast your technology is. If it's fragile and it keeps breaking and falling over all the time, that's not good. And also it requires to have, these days, increased levels of manageability, decreased amounts of management time. So, which is more reliable? Which is easier to set up and manage? Fibre Channel differs from iSCSI in a number of ways. Transport medium is one of them. So, Fred, what would you say to the reliability and management issues?
Well, I think that both, when you're comparing apples to apples, are going to be very similar, particularly when you turn iSCSI Digest on, or when you have a hardware-based iSCSI, then they're going to be pretty comparable when it comes to reliability. For manageability, I think it's easier to expand a fiber channel network. You just plug it in and it works. There are substantial tools available in fiber channel environments for monitoring and doing troubleshooting, but this is one I have to give to the Ethernet side. I think they have a broader set of monitoring and troubleshooting tools available because there are more people that are writing those kinds of tools. There's a lot more freeware and things that can be involved in managing Ethernet networks. I do think that Fibre Channel has fewer options, so that makes it easier to manage and easier to configure. So that's
Okay,
sort of...
Well, again, I'd have to largely agree with Fred. On the reliability, my take on it is Fibre Channel, has, as there are fewer options set up. I would say Fibre Channel, you just set it up and it's going to be very reliable. With Ethernet, you can set it up, and with iSCSI and Ethernet, you can set it up. And I'm not talking just at the CRC level. If you do set it up for maximum reliability, it's going to be just as reliable as Fibre Channel. If you don't, if you set it up without the redundancy or without, with less management, then it may not be as reliable as Fibre Channel. So I think the short answer is, from reliability, iSCSI can be just as reliable as Fibre Channel if you set it up that way. But you don't always set it up that way. In terms of manageability, again, I'd go with what Fred said. Probably initial setup and is simpler and easier with Fibre Channel because perhaps there are fewer vendors and then the options are better known. But Ethernet has a larger and I'm not sure, well, perhaps more scalable or larger ecosystem of management tools and vendors, just because of the larger scale of Ethernet network deployments.
So my comment on this would be one, I'm beginning to see a lot more emphasis placed by consumers of these products on manageability and reliability. People are no longer wanting to micromanage, and they're particularly wanting high degrees, high levels of robustness. And I think that's become a key criteria for storage buyers. It's not just speeds and feeds anymore. It's speeds, feeds, and how you actually go about making this thing, A, stand up regularly without falling over regularly, and B, reduce the amount of management time. I think that, we used to have a metric, didn't we, which was terabytes per full-time equivalent in terms of a storage manager. Well, we must be. We've got to be thinking in terms of the, petabyte, exabyte range for this sort of thing. We can't be having large armies of people maintaining and nursing these products. So I think the management reliability aspects of these products must be getting better. It's demonstrably better, and it's making people's purchasing decisions a lot easier than it used to be. Somebody, by the way, has sent me a quick note, and it wasn't really a question, and it was basically, it boiled it down to, and it won't be in our question and answers, by the way, it was, yes, X is dead. So I'm not going to tell you what the X was, but the person who wrote it knows. So let's move on to question number 3.
Probably the X11 video displays that were back in the 80s.
Okay, right, we'll leave it at that. I think the X was substitutable for something else. Anyway, question 3, and this is actually one dear to my heart as well. It's all about cost and price are not the same thing, but effectively, how much does it cost you to buy this stuff, and vendors in terms of the competition, the innovation, and interoperability. Fred, from a Fibre Channel perspective, what's been happening over the years in terms of cost, and where are we in terms of Fibre Channel vendors?
Well, cost has been coming down when you look at it in terms of, cost per gigabit of transfer speed. And again, we have to compare apples to apples. I believe you can, in an iSCSI environment, build a lower cost solution. But it's because you're giving up something to do that. And I think that's a case where iSCSI has more configuration points. They have more price points that they can come in at because of the different options that they can offer. Fibre Channel has fewer options. Everything is hardware offloaded. Everything is basically the equivalent of an Ethernet DCE switch with all the buffering necessary to make the thing run at full speed all the time. It's not an underperforming switch that is just enough to make email work. So you have to really be careful about how you compare price and look at what you're getting for that price. As for vendors, yes, there has been some consolidation, so there are fewer vendors now than there used to be. Everybody remembers the B, the C, the E, and the Q, the 4 primary vendors in the fiber channel space, and Ethernet has many more than that.
So in terms of, so you're saying for the acquisition cost, and I suspect that's a really good point, basically the features and functions are baked into Fibre Channel and you're paying for those. They're optional extras on iSCSI and you'd have to pay for those too. Is that the thrust of your argument?
Yes.
Okay. John?
Yeah, so on the acquisition cost, as Fred mentioned, there's a lot more variability on the iSCSI side. If you just look at network bandwidth, I'd say Ethernet is less expensive on a per bandwidth basis or per port basis, largely because there are more vendors and more port shipping for many purposes, not just for storage. But what you said is also true, that Fibre Channel comes with a certain amount of offloads and management features built in always. With Ethernet and with iSCSI, you have a choice. You can pay extra and get some of those offloads, and get get non-blocking switches and set up your network so that you have the full redundancy, or you don't have to. So you can make it much lower cost. Generally, I would say just on a per port basis, and this doesn't account for all the manageability and features, but I would say I'm seeing 100 gig Ethernet come in at about the third the price of 32 gig Fibre Channel on a per port basis. But then again, as you and Fred mentioned, if you want all the manageability and features that you have in Fibre Channel, then you have to spend more on the Ethernet side to get that, either on hardware or software. In terms of the vendors, definitely I feel, as I mentioned, that having more vendors on the Ethernet side, it's not exactly 6, depending how you look at it. It could be 6 or 8 or 10, whether you're looking at the Ethernet adapters or the switches. And depends what kind of switches and what kind of adapters. But that higher number of vendors has led to more competition, which has led to the prices going down faster on the Ethernet side. The prices are also decreasing, price per bandwidth have also been decreasing on the Fibre Channel side, but going down faster on the Ethernet side. But perhaps that could mean that in some cases you have more work in terms of interoperability testing or manageability if you're setting up a system that has multiple vendors on the Ethernet, so on the iSCSI side, versus a system that has really just 2 vendors of adapters and 2 vendors of switches on the Fibre Channel side.
It's what my grandmother used to call it. She liked the occasional brandy, and sometimes put a bet on the horses. And she used to call horses for courses. She'd say, you pick the horse for the course it's running. I suspect the same is true of Fibre Channel and Ethernet. God bless my granny. So, challenge question number 4. This is one that's becoming more and more important. I think security is way up there in a lot of people's thinking these days, particularly in terms of data breaches. We're becoming a bit more security savvy than we ever used to be. So Fred, which is more secure, do you reckon? How would you describe security in Fibre Channel? Well, I'm doing a compare and contrast. What are the facilities that it's providing that make it a secure environment to run your storage network on?
Well, Fibre Channel has both authentication to make sure that the endpoint you're talking to is the endpoint you think it is, and it has encryption to protect any data that's flowing over the wire from being snooped or being tapped into. So those are the same kinds of capabilities that iSCSI has. So LUN masking is a storage feature. That doesn't matter what protocol you're using underneath it. If the storage has that capability, then it can do it on whatever transport it's going to use. As for air gap, that's really a mistaken security concept. These days, most attacks at your storage are going to come through your host, and it's not going to matter whether your storage is air-gapped or not. Now, if you're running an iSCSI network on a shared environment where Ethernets and or emails and HTTP traffic and everybody's watching YouTube and Netflix is all flowing over that same wire, then you're going to have some higher risks of things on that wire potentially attacking your storage that than you really want to have happen, but that's a function of how you configure your storage network and not a function of the protocol. It just happens to be that with Fibre Channel, it's always air-gapped.
Okay, John, I've got an ancillary question for you, John, when you finish as well.
Okay. Oh, should I answer this first before you add the...
Yeah, answer this first, and we'll do the ancillary at the end.
Okay. So I would agree that Fibre Channel is always an air-gapped network. With iSCSI, you can make an air-gapped storage network, or you might not. You might make it a shared network. And different, as I said, horses for courses, different customers make different choices in that area. Perhaps the difference is that if you have one shared network, then the storage network is theoretically exposed to the Ethernet storage network is theoretically exposed to attackers. But on the other hand, Ethernet has developed a very mature and diverse set of security tools and vendors precisely for this reason, because Ethernet is used so widely for the internet and YouTube and other compute traffic, that there are a lot of security tools and vendors and monitoring and intrusion detection that you can use, as well as, of course, the encryption and the authentication capabilities. But it's up to the customer to decide how much of the security tools they want to implement. So I think just if you look at the storage network at a theoretical level, Fibre Channel might have a security advantage by being more isolated with air gap. In that case, as Fred said, anyone attacking would probably have to try to attack through the hosts, or through the Ethernet connections that go to for management purposes to the storage. While Ethernet is sometimes air gap, sometimes not, but it has, again, maybe a bigger and more mature, it's had to develop a more mature community and standard of security, just because there are more threats on the Ethernet side. What's the other question, Alex?
The other question was actually one you answered. It was about the fact that Fibre Channel was possibly a more difficult technology to tap into you can't really tap into a Fibre Channel network the way that you can into an Ethernet network, because the Ethernet network is more ubiquitous and better understood, I suspect. But I know that
I would agree that the hackers have more experience attacking the Ethernet network, and the defenders and managers have more tools and practice trying to defend it.
Yeah. Again, it swings and roundabouts. Okay, thank you both. So, my favorite question is always about use cases. John, I would like you to take it first. Use cases. What are the best applications for each, and are there any particular preferences? When we started these slides, by the way, we had the word love in there, but we took love out because I felt that love was too strong a word for a piece of fundamental technology like iSCSI or Fibre Channel. So who prefers it? What are the best applications, and who prefers it?
Well, Alex, I love my high-speed networking. I don't know about you, but I love it. So at a very general level, I would say Fibre Channel is preferred in the enterprise for what I term traditional mission-critical applications like Oracle, SAP, many deployments of VMware, and Ethernet tends to be preferred in the cloud, in people who want to have a single converged network where they can run compute traffic or different types of storage traffic. So if the customer wants to have one network that can run not just block with iSCSI, but also file or object storage on the same network, then they may have a preference for Ethernet. And then interestingly, some of these industries illustrated here, for certain applications, they might choose both for different, the company might choose both Fibre Channel and iSCSI and other Ethernet storage protocols for different use cases. So for example, if I'm an aerospace company, I might run my back-end business financials on a Fibre Channel SAN, but then I'll run maybe my email on iSCSI, and maybe some of my Microsoft storage or applications on iSCSI. And then when I do my product development, I might actually use NAS, NFS. And I know, for example, NetApp storage products support generally, depending which one, support Fibre Channel and iSCSI and NFS.
Thank you. Fred, where do you see Fibre Channel scoring? Where do you see Fibre Channel being much of a preferred by a particular industry or a vertical?
Oh boy, you're asking an engineer a marketing question. That's a tough one. I know financial institutions are some of the big places that are into Fibre Channel. They like the speed, they like the reliability, the dependability. As John said, email tends to flow over Ethernet, so people are moving email servers onto iSCSI. But there are still some places where that, just everything is used on a fiber channel. All the block storage is there. And I think, the applications that run the business, I think, are some of the ones that Fibre Channel is a good place for. Remote geographic replication. There are many applications that use the Fibre Channel environment for that because of the way the connectivity is set up and how the replication works. So generally, the differentiator that I personally use, and I'm not representing my company here, is if it fits in my head, then I can do iSCSI. But if it's bigger than that, if it scales beyond what fits in my head, I probably need Fibre Channel.
So I would actually argue slightly differently. I would say at a storage network level, Fred, you're correct, that if I'm building a storage network in my data center that for up to a certain size, I might use iSCSI. Beyond that, I might use Fibre Channel. But I would say if you go beyond that and you're doing cloud scale or scale out, then there's a good chance they're going to go Ethernet, though it could be a mix at that point. It could be a mix of iSCSI and other protocols like file protocols.
Well, I think that's a great discussion, because when you start talking about the cloud, there are really two sides of the cloud. You've got the part on the outside that you see, and yes, that's going to be a TCP/IP kinds of environment. But once you start looking on the inside of the cloud, who knows? That's the part you can't see from the ground. And that could be Fibre Channel, that could be iSCSI, that could be S3, that could be something completely different.
Remember when you started this, guys, I said no fighting. So,
wait, where did I put my boxing gloves? Let me go find them.
So very quickly, because we're coming towards the end of this presentation, I just wanted to talk very quickly about the future. John, can you describe the future in terms of NVMe over Fabrics, and hyperconverged? Where do you think that's going in terms of iSCSI?
Okay, just looking at the time, I'll try to be quick here. First, NVMe is going to be deployed in more storage. It'll make the storage faster. Therefore, people will want faster connections. And that could be faster fiber connections or Fibre Channel connections or faster iSCSI connections, or it might be faster connections running NVMe over Fabrics or other protocols, like possibly NFS or SMB. So that's NVMe. It makes the storage faster, and therefore the networks need to be faster. NVMe over Fabrics, well, it also will tend to require, it's a more efficient protocol, it will tend to require faster networks. It will, in some cases, replace the Fibre Channel protocol, but still run on a Fibre Channel network, or replace the iSCSI protocol, but still run on an Ethernet network. So I'm not sure, I wouldn't say it would replace one or the other more, but it's going to cause some changes. And in some cases, it could, it could cause the expansion of faster storage. It will drive people to deploy faster storage networking, whether it's on Fibre Channel or Ethernet. Hyperconverged can be an alternative to either a Fibre Channel or iSCSI SAN, but it won't replace everything. There are definitely enterprises who are they are deploying and will deploy more hyperconverged, which pretty much always runs on Ethernet, but they can't use it to replace everything. So it won't replace all the iSCSI or all the Fibre Channel.
Okay, thank you. And Fred, your final
I agree with the last statement that it won't replace everything. SSDs have been game-changing. Things have moved away from any kind of direct connect. The SAS and SATA connectivity has substantially dropped off with the advancement of SSDs. It turns out the biggest change has been in the host stack, that NVMe has given hosts an opportunity to rewrite their stacks. Their original software was optimized based on knowing about rotational delays, and SSDs exposed the fact that that was a really bad idea when you no longer have rotational delays. So NVMe has done a couple of things. It's put storage directly on the PCI bus for faster connectivity of local storage, and it's put it on the very lower levels of the fabric protocols, for example, the RDMA protocol or the Fibre Channel protocol right at the lowest level. So that impact of those higher bandwidth buses is going to be seen with that NVMe protocol. But just as John said, hyperconverged still needs storage, and I think fabric-based storage is the way to go, be it an iSCSI or Fibre Channel fabric.
Okay, thank you. Thank you, Fred. So I'm going to very quickly skip over these two slides to get to the decision time piece. How do you decide? I think from today, I think there's been a couple of good warnings here about comparing apples to apples. Don't compare one thing with another when they're completely incompatible. The other thing to look at is in terms of as Fred puts it, and John may disagree, and we were starting a good argument there. How big is in your environment? If it's bigger than your head, I might want a solution that's Fibre Channel. If it's smaller than my head, I might want an Ethernet-based solution. John argues that might not actually be true given certain circumstances. So I think the question of Fibre Channel versus iSCSI is an undecided one, and it very much depends on what you as a business are trying to achieve, what kind of technologies you're comfortable with, and what kind of business issues you're trying to address, and whether Fibre Channel or iSCSI, or even both, because I have a large number of customers who deploy both quite successfully and at scale. So it very much depends on your own individual needs. Now, today we've had Fred Knight and John Kim arguing about various Fibre Channel and iSCSI topics. We've got more webcasts. There are quite a few coming up. The next live webcast is, as you can see, about performance benchmarking, if you're interested in that. We've got Everything You Wanted to Know About Storage with the Too Proud to Ask series that you can go and look at on demand. There's actually an FCI webcast about Fibre Channel when they're going to be talking about congestion, slow drain, and overutilization. And also there are some SNEER resources on iSCSI that you can go and investigate. You asked a lot of questions. We will answer those questions, and we will put them on the blog, and you will be able to read the answers to all the questions. As to this webcast, I'd like to thank Fred, I'd like to thank John for the great presentation, their interesting information, and I'd like you to rate us as you leave. Give us some feedback. Tell us what you thought of this presentation. Add a comment, ask for more information, whatever it is you might want, but we'd love you to rate us on a scale of 1 star to 5 stars. And as I say, the Q&A will be posted up, and I've already put in the presenter announcement the location where you'll find a PDF of the slides. But in the meanwhile, thank you very much for attending today. Thank you for all your questions, and thank you, Fred, thank you, John, for giving us a very interesting and, shall we say, not friction-free presentation. So enjoy the rest of your day. Thanks for attending, and good night.